Hey guys, so I just wanted to quickly do a video to show you what my sine graph looks like and what my cosine graph looks like, and hopefully you guys got something similar. If you were having troubles with it and you came to this video just to check and see, one of the things you might want to look at is click the setting. It kind of looks like a little wrench in the corner, and set up your X and Y axis so that your Y axis only goes from like -2 to 2, and your Y axis or your X axis goes from 0 to around 360. I chose 390 when I did it, just to make sure that you get the whole thing so that we get a degrees 0 to 360, because that's one full circle. And then we also just stay within our -1 and 1 for our y-axis. Otherwise, it's really hard to see the graph. So hopefully you figured that out. If you didn't and you came to the video for that, I hope this helps and you can go back and try that. Anyways, I did I graphed them in Desmos, and I am going to quickly go through a couple things that happen when you graph them. This is the sine function. This one here is sine. And what you'll notice is we start at 0 here. It goes all the way up to 1, comes back down, crosses at 180, goes down to -1, and then comes back at 360. And it actually starts the process over again. So it's kind of like a wave. And that's what you'll get with these sinusoidal functions, is they make graphs that look like waves, or they're called periodic functions. So you may see that term as well, periodic. A couple things I want to go over in terms of features of the graph, and kind of point out some things that we're going to make reference to in lessons in the future. So the first thing is what's called amplitude. So amplitude is the distance from the highest point to the middle point. This is the amplitude. Now in this graph in sine, the amplitude is equal to 1 because the distance is from 0 to 1. You also get an amplitude this way. Again, that's our amplitude. And notice it's from 0 to -1. Which means it's an amplitude of 1. So some people call these hills and valleys, but basically the amplitude is the maximum distance away from that middle point of your graph, or that middle line of your graph. In our case, it's the x-axis. Okay, the other thing I want you to notice is the amount of time it takes to go right back to where we started, which is over here. That whole thing from 0 all the way over here to 360, this is called the period. So the period is the distance or length of time or degrees that it takes for the graph to return to the starting position. So it started here at 0, and it took all the way to 360 degrees for it to return to where it started. So our period for this graph is 360. A couple other things, our max and min. Our max is at 1. Our minimum is at -1. We can see it here, right here. Another thing it might ask is what your x-intercepts are. Notice for sine, it is at 0, 180, 360. It crosses again. And it will keep going. It'll keep crossing the x-axis at regular intervals. The other thing, our y-intercept, which happens to be where the middle of our graph is, in this case, is at 0, 0. Okay, The last two things I'm going to ask you is the domain, and so the domain of this, you can see it can be any x-axis. So our domain is x is in the set of real, and it can be any of those. But our range is what's most interesting here. In this case, y is in the set of real, but it's between two different numbers. And in this case, it is between -1 and 1. So I'm going to say that y is between or equal to -1 and 1. And I'll put the brackets around it. So that's what you should get for sine. I hope you were able to get those answers and see those things, but also that you're able to pick up exactly where the amplitude is and where the period is, because it's going to come into play in some of our later lessons when we start manipulating these graphs. Let's take a look at what happened with cosine. Oh, so this one here is the cosine. This is cos of x. And you'll notice it looks a little bit different, but it does have some similarities. Now, this one actually starts at 1, and it goes all the way down to -1 here and comes back up to 1. So when it comes back up to 1 where we started, that's our period. Okay, so again, we've got a period for this one of 360. Again, you can see the amplitude here. It's also here right at the end and right at the beginning. Those are all amplitudes, and you'll notice they're all equal to 1, just like the other one. Our max then is 1, +1, and our minimum, as we can see, is at -1. Let me write that a little bit better. Okay, very similar. It's just that our x-intercepts are a little bit different. This time it intercepts at 90 and 270, so our x-intercepts 90 and 270. And our y-intercept is different as well. It starts at 1. Lastly, let's do our domain and range. Our domain, again, x is in the set of real because it just keeps going. And our range, very similar to our sine function because we are staying between -1 and 1. So again, I'm going to write y is in the set of real such that it's between -1 and 1. Okay, so notice they're very similar. They just have a little bit of a different shape. Where sine makes the hill first and then comes down and makes a valley, cos kind of looks like a giant valley because it starts right up at the top, starts at its max, goes down to its minimum, and then comes back to its max. So they look a little bit different, but they also look really similar. And we're going to see that in some of the future lessons as well. So hopefully your lessons look the same. Again, guys, take a picture of your graphs so that I can, or your notes so I can see that you did this, and that will count for your marks for today. Okay, bye.